In this video, we're going to look at some ways that we use arrays. Now, arrays store a lot of related data. That's just kind of the nature of how we use them. Because we're storing related data, a lot of times we're going to need to do one of two things. We're going to need to either do something like sum up our data or find the average value of our data, or we're going to need to find a specific element of data or see if maybe it exists. So for example, let's say I had an array of student numbers. I need to see if a student number was still active. I would have to perform a search. Now, I've happened to have created a little mock file here that has a bunch of information and it has some random values that's going to be pre-sorted for us. I use a set random values function. I pass in my values, and because it's an array being passed by reference, I can modify those values directly. I initialize my random number generator, and then I use a for loop to simply step through and get a random value. To make sure that I'm always increasing in value, I have a special variable called last value. I always append to my random value. What that does is that just makes sure that my new value is always bigger than my last value. So that's how I'm creating a set of random values that are always increasing in size. So I'm going to look at first, how do we do a linear search? I have at the top of my file some function prototypes. Notice I have a linear search and a binary search. We'll look at that one in just a minute. Up in the top of my file, I have some function prototypes already defined. One obviously is my set random values. I have an item to find. This is where I'm going to just get a random value that I want to be able to search for. This way I know that the search value exists. And then I have a linear search and a binary search. Notice that with both the linear search and binary search, the same three values are passed in. My array, my array size, and the item I'm searching for. Okay, so let's look first at our linear search and how we're going to find this value. I can come down here to my linear search function. Now in my linear search, I want to return the index that I find my item at if it's found. The other thing I'm going to do is in a linear search, kind of like the name might suggest, I'm going to search every item inside my array linearly. That means the first item, then the second item, etc. So let's take a look at how we're going to do that. First, I'm going to set up a return value. Or in this case, I'm going to call it return index, and I'm going to give it an initial value of -1. If -1 is returned, that means that my linear search was unable to find my return value. Now I'm going to go through this process of finding my return. So I'm simply going to say for int I equals 0, I is less than my array size, and I++. Inside my for loop, I'm going to say if values I is equal to search item. Remember, whenever I'm checking for equality, I have to use the double equal sign. Then I'm going to set my return index equal to I, and I'm going to break. The break is going to exit us out of the loop because we found our item. We don't need to keep on searching anymore. Finally, I'm going to return my return index. So I always have a value to return. It might be -1 if the item's not found, or it's going to be the index if it is found. The way we'll set this up inside of our main function is very simple. We have an item index. It's an integer data type. It's going to equal our linear search. In our linear search, we're going to pass in our values, which is our array, the array size, which is array items, and we're going to pass in what we're searching for, which is search value. If the item index is -1, we'll just print out a little error message. If it's not equal to -1, we'll have an else. We're going to run this file real quick. Here's my array. You can see all my items. They're in increasing order. And I was able to find the item at index 22. If I run this again, this time it's at 58. I'm going to keep running this a couple times. Here it was at 74, which is our very last index item. And this is going to be a real problem because my linear search requires that I go through each individual item. So I could have 1,000 items in my array. I could have 1,000 checks where I want to check to see if that value was. So this becomes kind of slow. And the reason this becomes an issue is as my arrays become larger and larger, then I have to do more and more checks. 1,000 items can become very time consuming. Now, in a modern computer, it's not as bad as it used to be, but it's still not a very efficient process. So why would we even want to consider a linear search? Well, what happens if my array was not sorted? Then I would have to use a linear search. Or when I start dealing with complex data types, where I have multiple pieces of data involved, I might be sorted on, for example, a person's last name, but I'm searching the person's student number. Because they'd be sorted by last name, it probably is not sorted by last number. So while my linear search is not really efficient, it is very easy to write and something I do have to use periodically if my data is not sorted.